Okay, let's start. Hi, my name is David Voyage, and this session is called Test-Driven Development. And this session will be in 3 parts. The first part will be about unit testing. What is it and how do I write a unit test? And the second part will be about test-driven development. What does that actually mean? And finally, we are going to talk about the real world. When developing in an existing code base with those endless lines of code, untested code, where do I start the test driving? Okay, let's start. First, before I start with coding, I would like to say that unit testing is not complicated. It's not complicated at all. A unit test is just a simple class, a C# class. So let's go ahead and create one. I'll open one in Visual Studio. So I have prepared with a solution and a couple of projects. We'll get back to those soon. So let's start by creating a class. And I will name it example. And let's remove some of that unnecessary lines of code, and I would like to add public here. So with unit testing, you could say that class is a container of one or more unit tests. And a unit test is just a method. So let's add one. My unit test. Fine. Okay. The next thing we need is a unit testing framework. Well, actually we don't need it, but it's so much easier than writing one by yourself. And which unit framework should we use? Well, there are a lot of unit testing frameworks out there. For example, you have built in with Visual Studio, you have MS Test. But for this session, I will use NUnit, because that's the tool that I use on a daily basis. And NUnit is not included in Visual Studio, so we have to get it from either from the NUnit website. You can see it here. You can read about NUnits, check out the documentation, and download the MSI file. Or we could use NuGet. Let's do that. So I will right-click my references folder and choose Manage NuGet Packages. Online and search for NUnit. Where are you, NUnit? There you are. Okay, let's just hit the install button. Boom, we're done. So now we have all we need to start creating our unit test. And for making NUnit understand that this class and this method is is used for unit testing, we need to tag them with attributes. And for NUnit, you write this attribute, test fixture. Oh, and let's add a reference to NUnit also. And for each method, each method that is a unit test, you should add the attribute test. Fine. So if you would use MS tests instead, you would write test class up here, and for each method you would write test method. So NUnit and MS test are very similar. So just by adding these attributes, the test runner in Visual Studio will recognize these as unit tests. And I use the ReSharper test runner because I like it, because, well, I'm a fan. So as you can see, it has it shows it right here. So what does one write in a unit test? Well, a common scenario is to compare values. Let's say that you execute some code, you execute a method and you get the return, the result. And you want to check if it matches your expectations. And one way of writing it is something like this. If x, if that would be your return value, equals to y, then we are okay, the test passed. Otherwise, else, we have to write some fail code logic here. But when you are using a framework like NUnit or MS-test or something, this is not the way you should write a unit test. You shouldn't write your testing logic like this. So let's remove this. Because what comes with NUnit and MS-test is a class called assert. And that class contains a lot of useful methods for comparison of values, for checking if an object is empty, etc. and so on. So for this case with the x and y, I would use the first one here, r equals. So I would write something like this, x, y. And you can actually say that the assert methods, or this assert method is the actual test of this method. This is the place where we perform the actual test. Okay, so let's continue by creating a real unit test. I'm going to throw this. I'm going to delete this example. Delete. Boom. And let's talk a little bit about the solution and these projects here. I have built an app, a calculator app. Let's take a look at it. It's very, very advanced. It has one method called add that adds 2 integers and returns the sum of it. So I would like to unit test this. And how should I do that? Well, let's take a look at the solution again. A common structure or a pattern perhaps is to put all your unit tests in a separate project, and name that project, let the project have the same name as your source code under test with the extension .tests. I have prepared that for this session. And this project, of course, has to reference the project under test. So let's add a test class for this calculator. So I'm going to name it calculator tests. And let's remove some unnecessary code here. And now I'd like to add this public stuff here. Okay, so we're going to add this unit testing attribute, test fixture, and add a reference. And let's start creating our first unit test for this calculator. Adding the attribute here and public void my unit test. But wait a minute, this name isn't very good. It's actually quite bad if you ask me. You shouldn't name your unit tests like this, like my unit test or test 1 or test 2, test 3, etc. Try to name your unit tests so that they describe the intentions of the test method. So in this case, what we want to do here is test the add method, that it should add two numbers. So I would probably name this method add two numbers. Okay, what should we do then? Well, we have our add method, so let's start, sorry, we have our calculator, so let's start an instance, let's create an instance of it. New calculator. And then we want to execute the add method. And let's send in 1 and 2, and we want to get a hold of the result also. Okay, so now it's time to make an assertion here. Assert, and I will choose the first method here, are equal, and my expected value should be 3, and I want to check the results if that matches those expectations. Let's run this method. Sorry, let's run this unit test. Boom. It passed. Great. So let's just take a look at what we have done here. First, we kind of made a setup of something here. And then we executed some code, and finally we made the assertion. And that is a pattern or a structure that many people call AAA. And AAA stands for arrange, act, and assert. And I would very much recommend you when you start your unit testing to structure your unit tests according to that pattern, because at least for me it helps me, it points me to the right direction very quickly, what I actually want to do with this unit test. So that is recommended. Okay. So, what should we do now? What about test-driven development? What is that? Well, I'd like to call it a method, or maybe even better, a tool that helps you create high-quality software. It's not a guarantee that your software will be better, but it probably will help you reaching your goals. So how would I write this calculator in a test-driven manner? Well, I think we should go back to the requirements. Let's say that we have a customer that asked us to create a calculator that can add 2 numbers. So I'm going to remove all code here. Remove the calculator, remove the tests here. Because if I would start in a test-driven manner to write code according to those requirements, I would start by creating a unit test class and not start coding the calculator itself. That may sound a bit weird if you haven't worked like that before, but that's test-driven development. That's how it works. So let's start by creating a class here, a test class. And I will call it calculator tests. I'm going to remove some unnecessary code like I did before here. And let's add those n unit attributes. Test fixture. and let's add our first unit test here. So our requirements said that we should add, have a calculator that adds 2 numbers. So let's name our first unit testing method something like this: add 2 numbers. And let's use that AAA pattern: arrange, act, and assert. Okay, so what do we want to do here? Well, I would like to create a calculator that can add 2 numbers. Something like this. And I want to get the sum of those in as an integer. Something like this. Okay. So if I would try to build this in Visual Studio, it would fail because the calculator doesn't exist and these parameters doesn't exist either. So let's create those parameters. Fine. And I want to start by creating this calculator now. So okay, let's go to the calculator app project and add this class. Calculator.cs. And switch back to our unit test. Good. It recognized our calculator, and now it's time to continue with adding this method, the add method. And I'm going to do it with using resharper this time. So let's create this method. Good. I like these methods. Fine. Okay. Let's make the whole class static. Fine. Okay. Now we can at least compile. So let's do the assert here. Assert are equal expected and the result. And I haven't created this variable yet, so let's do that. Okay, let's run it. I'm going to run it from this shortcut that is provided by resharper, which I think is very neat. So it failed, and that shouldn't be a surprise because I think you saw that the add method just threw an exception, returned an exception, and you get a pretty good overview of what happened and what failed. You see what happened here and which lines are affected. So let's go to the class and the calculator and the add method here and create some code that works. Something like this. And let's run it again. Okay, it passed. Fine. So let's take a step back and think about what we did here. Well, we started from nothing really, and I started creating this unit test method, and I was thinking about creating some kind of calculator and an add method that can accept 2 parameters. Then I went on and created that calculator and went back and forth creating that so that until the test passed. So you could actually say that what I did here was designing this app, this calculator, and I think that's perhaps the greatest benefit of test-driven development, that you actually, it's like a lab. you actually think, write, and create stuff within this unit testing method. So that is something that I think is a great benefit from test-driven development. And perhaps you notice something else. This calculator is a bit different from the one we used earlier. You can see that the add method is static. In fact, the whole class here is static. And when I was creating this class here in a test-driven manner, I didn't even think that I would need to create an instance of a calculator and then calling an add method. I thought I had kind of, you can say that I had the perspective of a user when I was writing this code before it existed. So that's another benefit of, as I see it, of from test-driven development, that you have this user view that will probably help you create very effective code, and hopefully code that is easy to understand. Okay, so let's say that our customer calls us again and says that, okay, that's fine, but I would like you to add something to our calculator, because adding two numbers, that's kind of silly, isn't it? I would like the calculator to be able to add a lot of numbers, an infinite amount of numbers. Okay, let's do that. So how would I do that in a test-driven manner? Of course, I would start by creating a new unit test. Let's do that. And I will name it something like this: add many numbers. Okay, let's use that AAA pattern this time also. Arrange, act, and assert. So what do I want to do? Well, I want a calculator that can add numbers something like this, a lot of numbers, and I still would like to get back a sum, a result from that. And the expected value should be let's see, 1, 3, 6, 10, 15, right? And let's go ahead and make the assert. R equal expected and result. Well, as you can see here, this won't, if I would try to build this, it would fail, because this existing add method doesn't accept more than two integers. Let's go ahead and modify this calculator. And how can one do that? Well, one way is to do something like this. I would like to return a sum of these numbers. And how about doing something like this? For each number in the list of numbers, add this to the sum. Okay, looks good. Let's go back to the unit test and run it. I'm going to run it here from the ReSharper view here. Wow, it works. But how about this, the previous unit test that we wrote before? How about, does it still handle these two input parameters? Let's run them all. Run them both. Good, it works. So you could say that I think this is another benefit of test-driven development or unit testing in general, that when you're changing stuff, you can always run your existing unit test to make sure that you have not broken any existing functionality. And I saw something here in the calculator that ReSharper suggests that I can convert this to a link expression. And you know, whatever ReSharper says, I'll do it. So let's do that. Wow. It turned my method to a single line. But how about, does it still work? Well, let's run the unit tests. Fine, it works. Good. So if you are like me, a bit unsure about those fancy link functional programming stuff, unit testing is a good help for you. Let me see the Q&A here. Okay, the question is, why you name test using underscore? Is it a convention? Well, I think so. You can write your unit test in your however you want. I think these underscores makes it more like more readable, and more readable in the unit test runner. It looks like a sentence, I think. So that's why I do this with underscores. Is there a public standard or a de facto standard? Well, I don't think so. Actually, there are a lot of books about test-driven development, and they suggest different stuff. The main thing is to name when you're naming your unit tests, do that so they describe the intentions. That's the important thing. Okay, HTTP context session and mock-U. Well, I will talk about mock-U a little bit later, but I won't touch HTTP context in this session. We can talk about that in the chat room later, maybe. Okay. So that was unit testing and test-driven development. I think we should talk about the real world. And you know, as a consultant, I have seen some common patterns in software in different companies. And usually the software looks something like this. Let me just switch to the PowerPoint here. Let's say that it's software that creates a website. So we have a layer that is the web that communicates with some sort of domain layer or domain tier, and that domain tier in turn talks to a data layer that kind of wraps some data source of some kind, maybe a database or a third-party service. And as example, let's say that the web should display user info. So the web sends a request to the domain that asks for data in a more raw format, and in return it gets data and kind of creates a domain-specific user object that it returns to the web, and the web displays it. That's fine. Nothing wrong with that. Let's take a look take a look at the code about how that could look like. So I have created an example project here. Let's run it. It's just a simple website that displays a username and the age of that user. What about the code? Well, I have made this, as you can see, it's this 3-tier site. It's a web layer. You got the domain and you got the data. And the web is a MVC project. So we have a controller and a view. Let's take a look at the view. The view just displays, gets a user object that has name and age, and just print it out on the site. And the controller has this index method that creates an instance of a domain service that lives in that domain layer, and then executes this get user method, and then return that user object that it gets from the domain layer. Let's take a look at the domain service. Oops, sorry. Okay, the domain service has this one method, get user. The get user method creates an instance of a data service that lives in the data layer, and then calls these two methods, get name and get age. And then it creates this domain specific user, object, and returns that user object. Let's check out the data service. Well, this is an example, of course, and you can imagine that in the real world, this would actually would call a real database, SQL database, or some sort of data source, maybe a third-party web service or something. So I would like to start unit testing this project. Where do I start? Well, remember when we talked about the structure of the solution and project. So what I'm going to do now, I'm going to create a new project for my unit tests that will have the name legacy.web.tests. So let's create one. Add new project. It will be a class library. Legacy web tests. And I'm going to remove this class that you get from default, and I'm going to add the reference to the legacy web project here in the test project. So add reference legacy.web. Okay, let's start by creating a unit testing class. Simple class, now we'll name it home controller tests. And let's add this unnecessary lines of code. And what do I need now? Well, I need to add the NUnit framework. I'm going to use NuGet this time too. Manage NuGet packages online and search for NUnit. There you are, install. Boom, done, fine. Okay, so let's add our attributes to this class. Test fixture. And add a reference to NUnit and start creating the unit test for the home controller. And what I want to test is that the index method returns a view. Fine. We got our AAA set up here. So I'm going to create an instance of the controller. New home controller, add the reference here. Okay, I need to add the MVC too, fine. And then we're going to call the index method. Index, and get the result from that. Good, so what should we do now? Well, let's settle with checking if results that it isn't null. Assert is not null result. Let's go ahead and run it. Well, it passed. But wait a minute. What have we done here? Well, we have used this pattern. We have created an instance of a controller and executed the index method. But if we take a look at this index method, it actually calls the domain service and execute this method. And if you remember, the domain service calls two other methods that exist in the data service. So what our unit test actually really does is it goes all the way. If you remember this picture here, it goes all the way to the domain layer, to the data layer, and perhaps and probably all the way to some kind of database. And that's not really what we want to do when we create our unit tests. But this is often, at least that is my experience, how a lot of code out there in the real world looks like. So let's adapt to that. So what I would recommend you to do if your code base looks something like this is to create unit tests for each layer. You create a controller unit test, create a domain service unit test, and so on. So that when you're changing your existing code, you at least know that you won't break anything that's already exists. And there's probably somewhere along the way where the code looks up some configuration for a connection string to a database or something like that. And since we have all our unit tests in a separate project and run it from that project, we can actually add a configuration that overrides what the webconfig configuration contains. So you can actually, when running your unit tests, you could point to like a test database or some sort of fake data. Okay. So what if I had the chance to refactor all this code to make it more testable? How would I do it? How would I do that? Let's think about that. Well, the first thing, the problem is this row here. The index method creates an instance of the domain service. It's handling its own dependencies, and I would like to remove that dependency. We can start by removing it from this method. Let's do something like this. And add a constructor and create an instance of the service in the constructor instead. Okay. So instead of creating this guy over here, let's use the service method. Now at least we have removed the dependency from this index method, but we still have, of course, created a dependency in the constructor. I think we can make this one read-only. What I would like to do is, from my unit test, if we step back to the unit test, I would like to inject that service from this in the constructor, something like this. Within the reference, something like that, and we need to modify the the constructor so that it accepts a parameter. So instead of creating it one of yourself for ourselves, we just set it to the parameter. Something like this. But let's run this code in the browser. Okay, this message is in Swedish, but it says something like this: there is no parameterless constructor for the controller, and that is how ASP by default, MVC by default works. It requires a parameterless constructor. So let's add one. And within that, we will actually do like we did before, domain service. So it should be happy now. Let's try it again. Good, looks better. Okay, but when we run our when we run from browser, it will execute this constructor, and when we run it from the unit test, it would use this one. But the problem is we still use this the domain service class, and we still will go all the way. So in our unit test, I would like to send something like a fake domain service. And how can I do that? Well, instead of using the concrete class here, I would like to abstract that away by using an interface instead. So I would like that this domain service is of the type domain service instead. So that means that we have to create this interface. So let's go to the domain service, and for convenience, let's add it in the same file as the domain service. And let the domain service implement this iDomain service interface. So if I would remove this this method, you wouldn't be able to compile. Let's go back to the controller. Oh, it looks better. Fine. Let's go back to the unit test here. So we don't have a fake service. So I have to create one. I will do that with some help from ReSharper. And let's create that in the same file also, just for convenience. And implement these the member get user. Okay, so this one should return $37. So now we have kind of removed the dependency from for the domain service to use an interface instead. And from this unit test, we inject a fake service instead that the home controller will use. So when the home controller index method will call this get user method, it will actually call this method, and we got the full control of it, and we won't go all the way like we did before. And this technique is called, or this way of writing software is called dependency injection, or inversion of control. And that's a pretty common pattern when you are creating, when you're writing in a test-driven manner. Because what you do then is that you won't have any internal dependencies in the code that you test. You are injecting all the dependencies, and most likely you will use interfaces for that. So there's one more thing that I don't really like about this controller. We have two constructors here. Why do we need that? Well, that's because the runtime requires that. what I would like is to remove this guy over here, and I would like to like the runtime to understand that when it reaches something called a constructor that has a parameter of some type, iDomain service, it should understand which concrete class to use. And to being able to use that, I'm going to use a IOC, inversion of control framework, or what it's called. It's often called IOC container. And there's a lot of them out there too, and the one that I'm going to use and that I use on a daily basis is Ninject. Wow, isn't that cool? I want to use this one. So just like NUnit, you can download it from the site or get it from NuGet. So let's do that. And this time we're going to add it to the web project. Manage NuGet packages and search for Ninject. Okay, where are you, Ninject? Fine. And since this is an MVC project, I'm going to use this one. And this MVC3 stuff also works for MVC4 projects. So let's install it. Okay, I accept. Boom, done. So what Ninject has done, it has added some code to our project. It has added something to our app start folder here. So what do we want to do? We want to tell the runtime to use Ninject instead of its default way of creating controllers. We can, and that is done by using this class, Ninject Web Common. And there's a fair amount of code here, but the one that is interesting to us is the final one here, register services. So what we want to do here is to map the iDomain service to the concrete class domain service. And this is done by writing something like this. Kernel bind iDomain service. I think we need to add a reference, yeah, to domain service. And let's run the code. Let's run it in the browser again. Amazing, it works. So now if we go back to our controller here, now we have exactly the same code that executes both when you run it from the browser and when you run your unit test, and that's how it should be. So that was dependency injection and inversion of control with some help from that ninja. Okay, let's take a look at if I have some questions. You know what? I'm going to answer your questions just in a few minutes, because I have one more thing to demo. I would like to add one thing, actually. And what is that? Well, let's go back to this unit test. In this case, in this extremely simple example, we created this fake domain service. We created a class for it that implemented this interface, and that's fine for this kind of this level of complexity. But in the real world, when you develop large sites with a lot of code, or what if I extend this and create some more unit tests that need that makes this domain service that it needs to be a little bit more flexible. Then I have to start building some logic within this class, and that can be a problem. What I would like to do is not be I don't want to write this fake domain service. I would like to use a mock object instead of this one. And that can be done by another framework, of course. And there's a lot of mock frameworks out there also. And one that I particularly like and use daily is a framework called MockU, or Mock. And this can be downloaded from the site or from NuGet. I prefer NuGet, so let's download it from there. And this time, mocking is for unit testing. So we're going to add the reference in our web.tests project. And I'm going to search for MockU. It's pronounced Mock or MockU, I think. Install. Okay. Let's try again. Good, now it works. So we have the mock framework now in our references, and what I would like to do is I would like to remove this guy. And I would like to create something like this. I would like to create a mock object. Let's add the reference. A mock of this iDomain service. And this is how this mocking framework works. I tell this mock object to behave in a certain way when a method that exists within this interface is called. So, and this in MockU, it's done like this: mock setup. Setup for service, the service when the service get user method is called. Then it should return a new user object. Okay, let's remove this service. So I'm telling the mock object to, when this method is called, return this object. And instead of that old service, fake service, I would return this mock object. And with this framework, you don't actually return this object. You return a property of that is called object, and that is of type iDomain service. Let's build it and let's run it. It passed. So now we have full control over this dependency domain service within this actual unit test, with some help from this mock object. And you know, I will stop there with these mock examples, because remember when from the beginning when I told that unit testing isn't complicated? Well, it's kind of, well, okay, I lied. When we talk about mock objects, stuff starts to get a bit complicated. Sometimes, not all the time, but with mocking, it's a different level. And I would recommend this. If you haven't done any unit testing before, and unit testing, dependency injection, and all that is new stuff to you, I would recommend you not to as the first thing to start using these mock frameworks. I would use these. I would create these fake classes myself, because I think that dependency injection interface in unit test is you need to doesn't have to be an obstacle. You have to pass that first, I think, before you start using those mock objects. And you could say something like this, that when your own fake objects starts to irritate you, they're starting to prevent you from being productive, then it's time to start using a mock framework. And I would suggest you to browse the MockU website and read the documentation. There's a lot of good stuff there about mocking. So that's it, actually. That's my presentation about unit testing is about to stop. So let's start this this one. Let's check out these questions. So, is there a public standard for what you say? Okay, I think I've answered that earlier. That the main thing is to name your unit tests so that people understand, including yourself, understand what those unit tests are about to do. How do we test more than just check if the view is returned? If view has drop down, how to check if the drop down is populated? Okay. Well, you in MVC, the default return type is you can change the default return type to like view result, and that makes you enables you to access that model object that you have sent in. So you can check if the model has, for instance, a list of data, and check if the data is not empty and stuff, or stuff like that. Mock the HTTP context. That requires 1 extra hour, and that's not what I have. I'm sorry, but it's you can actually find it in the, if you use MVC, you can read about it in the asp.net/MVC site, and I think also in the MockU site. Do I recommend unit testing the data access layer? Well, yes. If it's something like the example here that kind of access some data, I would actually do that. That depends, of course, that depends what kind of logic you use. It's very difficult to answer that in a straight way, but maybe or maybe not. So, do I have any more questions? Okay, I will hang out. Oh, I will hang out in the Jabber chat room, and being able to answer some of your questions. And don't hesitate to, if you come up with a question later, send me a message on Twitter or an email. You can to me, and I will answer as quickly as I can. Thanks. It has been a great experience talking at this conference. Thank you a lot. Thanks a lot. Bye.